Hello, I'm Anna Mackay and this video is on domain and range, and it's one of two videos on that concept. A refresher, domain and range. The domain relates to the values that X can take, and range relates to the values that Y can take. Now, I don't know about you, but I always struggled to remember which was which. I knew the two words and I knew one was X and one was Y, but I could never remember which one went with which. You have to find a way to remember that. Here's one way. Might sound silly, but it worked for me. The Y, the letter Y, when you write it, has a long tail. And in the word range, which is related to the Y, it has a G, which also has a long tail when you write it. So that's the way I remember it, that they've got a sort of a letter that's got a similarity to them, and so range connects to Y. Anyway, that symbol there represents union or or. So when you see that in set notation, that's what that's referring to. This sign diagram, what values of X can that take? Between A and B, does it include A and B? Yes, what tells you that? The coloured in dots, that's what tells us it includes that. So it's greater than or equal to, and that's how we write that in that notation. And that's called set notation. So we look at the brackets that we've got here, written like that, and that is called set notation, whereas over here we have interval notation. And interval notation is written with X and that symbol there, and with the square brackets for inclusive. The way we read it is the set, this is for set notation, the set of all X such that X is between A and B inclusive. So another example, which values of X can this take? So it's values of X that are less than A, so less than A and heading towards infinity, but not including A because of that open circle. And values of X for B heading towards positive infinity, but it does include B. So the set notation for that this time round is the set of all X, so that's what that part means. For X is less than A, notice we don't have the equal to sign. Or, as we've said, that means or it means the union. So I guess it's the combination of these two facts. For X is greater than or equal to B. The interval notation for that is it means X belongs to the set, and we've got the two elements that we must define there. Notice when there's a round bracket and when there's a square bracket. Now notice the round brackets with infinity each time, because infinity is not a definitive number, so it's not like we stop there. So we have a round bracket for that. Square brackets are used when an interval ends at a closed point, as we've said. And round brackets are used when an interval ends at an open point or continues to plus or minus infinity. Handy to note down if that's something you forget. This is handy to have all of this written down, please, as examples. Right, so a number line graph. We're going to look at the different versions, the meanings and the different types of notation that we can have. So interval notation here is we've got X greater than or equal to 3. So we must have greater than or equal to and square brackets. The interval notation first is using that symbol, so it looks a bit like an E, but it's round. Square bracket for the 3, but round bracket always for infinity. The set notation, written like that, and it means the set of all X such that X is greater than or equal to 3. Next, this one. What would the interval notation look like for that? We'd have X belongs to, now 2 is our upper limit, so 2 actually goes on this side. Square or round bracket though, round, and going to negative infinity, and infinities have round brackets. So that's what that one is. The matching set notation with the line in between here with the X and the X, so less than 2, not equal to. And that's the set of all X such as X is less than 2. This one, think about your interval notation. So X belongs to the set. Think about your types of brackets, round on the left and square on the right, separated by a comma, -2 and 1. There we are. And the set notation, so that sort of curly bracket, and x belongs to the set between -2 and 1. So we put x in the middle, you put the greater than, less than signs, and with the 1 you'll add in the extra line, 1 here, a -2 on the left, and your curly bracket again. There we are, written neatly. And that means the set of all x such that x is between -2 and 1, including 1. One more. Having a think about this one, you're going to this time need the union, the U for union symbol in between here. There we are, just speeding this up a little. And the set notation, you still have your curly brackets, and your line for x, but you have the union in between. So that symbol does get used in both types of notation. And that means the set of all x such that x is less than or equal to 0 or greater than 4. So that's where that or comes in if you ever had to write that out into words. An example of a scenario where you may have this happening with some values equal to and then not equal to. The domain here are the t values, which are essentially the x values, and it can have every value between 0 and 24. So even, for example, on value 6, although it appears twice, on the upper one it didn't exist and it does on the lower one. Whereas the range here, it's actually got only a limited number. It exists here, 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 there, and just a few. So it's actually just a set of numbers in that sense, and it's these ones here. Notice the notation is the same in terms of we've got a curly bracket and then the line for the set of. So that stays the same if you're doing domain or range. Okay, let's practice writing these out. So first of all, we want to start with the set notation. So we have our curly bracket. For domain, always good to state which one you're working out. X belongs to the set. Let's have a think. What x values have we got? Well, we've got none to the left here in the negative region. X only starts at -1, but it does go on to infinity, positive infinity. So we would have x belongs to, cross that out. We've got x is, well, going to infinity. If this notation, I may have got that around the wrong way, greater than or equal to, -1. So all values of those are included. There we are. So that's that notation there. And the other one will have the belongs to symbol. Here we are. And notice the use of brackets. The range for the y values now, thinking about looking along your y, and you see, well, we've got nothing down here. So it's all values from this -3 up to positive infinity. So the range is from -3, just all of those values. There we are. This one here, values of x. Are there any that we can't have? No. Just because you can't see what's happening to the far extremes, you know that that's going to go on forever. So it's all values of x, any value. Now this symbol here is the real set of numbers. When you write that, the way you do it is with a double line for the r, and then you draw a normal r, and that implies the real set of numbers. And y, well, it's mainly from there down, so it's from that, remember, 1 is the y coordinates, and that lines up with 1 there, so it's values of y less than 1. Less than or equal to 1, we should add. Y cannot be, so y cannot be greater than 1, but it can be equal to. All right, and this one here, values of x, so we're looking along the domain here, what values of x we can have. Well, we can have all of them except at x is equal to 2. All values except 2. So you can just write that. Sometimes, for overkill, we sometimes write x belongs to the real set, comma, x not equal to 2. But if you do just write this, it's implied that it's every other value of x. And for y, you have a look along the vertical, up and down, and you can see, yeah, it exists for y everywhere except at 1. And these here, stating the domain and range. So domain is x, you have a look across, all values of x here, But notice it had an end point there. So there were actually no values of x after that point, so always less than 8. And y, you look vertically, and it was always from this -2 up, so greater than -2. And for our quadratic here, the domain, all real values of x, but y, the turning point there, the minimum, -1, all values greater than or equal to -1. Okay, the next video in this series is Domain and Range Part 2. Thank you.